this talk is about electroplating, not electroforming. I wanted to.
And what's the difference?
That is in the next slide. So, brief history. If anyone cares, electroplating. They used to say that the Baghdad batteries were evidence of electroplating, but more recent evidence suggests that that is not accurate. Electroplating really got kicked off in the early 1800s, and it got more popular in the 1830s, and so there's we've been electroplating for a while since then. Electroplating is putting metal on an object, resulting in the object being coated in that metal. Electroforming is a way of duplicating an object, and so basically what you do is you take a positive, you create a thin coat, then you remove that positive, and then you fill the inside of that coat with more metal, resulting in that duplication. So it's a slightly different process, but it involves electroplating. Can I disconnect this? Is this?
It's fine.
Oh, okay. So that is. That's the difference between electroplating and electroforming. Let's see. So, what is electroplating? It's basically you take a thing, that is electrically conductive and drop it into a bath of electrolyte, and then run electricity through that, and that causes the metals in the from the cathode to transfer from the cathode onto the surface of the anode, the thing being plated. I occasionally talk about how their safety is a thing. So. You can, so that's a this is an acidic liquid that you're dipping your stuff in. Yes.
Is the acid the poison, or is it the metal that's dissolved in the acid?
It's the metal. Yeah.
Okay.
Yep. So what was my other point in this? So the thing being plated does not have to be fully conductive. You can coat it with a conductive, you can add conductivity to it. I use graphite ink. I've seen some interesting stuff where people made an ink out of graphene, and that actually was more conductive. So. That's an opportunity to play with it, but we, yeah, a little bit. So that's basically what that is. So what is required for that? You gotta run electricity through it in order to convince the atoms of metal to leave the anode and go to the cathode. You need a tank capable of holding the liquid, and then you got your thing you're plating. There's a couple of ways you can set up your tank so that you can plate multiple things at a time. So there's bus bars that you can put across, and so that's that allows you to add to the square or to the surface area of the things that are being coated, which I think I mentioned a little bit in the previous slide that the amount of electricity, yes.
Where do you get titanium wire?
You can just buy it online, like, yeah, Amazon has it. Yep.
Thank you.
Yeah. The first point there was that electricity, the amount of electricity you're flowing through the circuit is proportionate to the surface area that you're coating, and so that, you know, that's the total surface area. So if you've got multiple things hanging off your bus bar, then that will, you know, add to the amount of amperage that you're running. Let's see. Okay, this is the slide I was on. And again, the copper anode. So the recipe that I used was the copper root killer. It's blue crystals. You buy it at Home Depot. Hydrochloric acid is pool acid. You can buy it by the gallon at Home Depot. Sulfuric acid you buy at what do you call it? O'Reilly's. So they sell like kits for replacing the acid in your battery or renewing your battery, and so that's, you know, that's where you can get that. If you go online and look at other recipes, the sulfuric, they actually, like, they talk about pure sulfuric, and so like you're adding much less, but the sulfuric acid that you have access to from O'Reilly's is you know, diluted somewhat. So it's a larger volume that you have to add in order to get the right amount of sulfuric. And then distilled water. I mentioned brightener here. That'll come back up. So when you're electroplating, the copper is moving across pretty efficiently through this electrolyte, and that is both a good thing and a bad thing. So what a brightener will do is it will change how fast the atoms of copper get deposited onto the thing being plated, and that will change some of the properties being you know, basically you can make it shinier. It will make it smoother, and so you get a little bit more I guess quality from if you add brightener. So I actually did include some pictures in this. Yes?
On brightener, does that change the like structural or resilience qualities?
Not really. Not that I've seen. It basically just, it can, if the copper is plating slower, it'll basically make, like, you, if it's plating very quickly, in other words your amperage is too high, then you'll actually wind up with random bumps and stuff getting put on, and
it looks like felt.
Yeah.
Or moss,
Mm-hmm.
instead of like
right.
flat.
That would be very high amperage for the surface area.
I made that mistake. Yeah.
Yeah. But so basically, this is a pretty simple recipe. You start off with your root kill, and then you dilute it in hot water. You add your acids to it, and you add your brightener, and so that's basically how that works. So let's see. There's more talking about brighteners. They're usually organic compounds, so that's, you know, just an interesting thing. The two that I've seen that made me really interested in them was one is a laxative that you can buy at at Walmart, and I haven't had a chance to use that yet. I went ahead and went with the cleaner route, or I don't know if cleaner is the right word. The slightly more expensive route. Caswell Part A and B you buy from the internet. Caswell has a website that you can get that stuff. It's relatively cheap. I think just a small bottle, like an ounce of the Part A and 3 ounces of the Part B were something like $30. Part B is used up as part of the process of plating, so you wind up buying more of the B because you're adding that back in, like as you're plating more stuff. Let's see. Yeah, I don't have much to say about the chemistry of it other than it's neat. But, so on this slide I've got, you can kind of see over here where the where this is not as shiny. It was kind of duller, and that goes back to this is pre-brightener, this is post-brightener. I plated both so I could kind of see what the what the difference was, and this can be polished. Like I used just like a buffer wheel on a Dremel to polish it up. It got shiny, but it came out relatively matte, and so that's why I basically was using a multimeter to check and actually see, okay, is this copper? And yeah, it sure was. But, so this is an example of an and I wrote electroforming, but this is electroplating. And basically the thing I did here was I took a Swiffer dry cloth and used basically what do you call it, hot glue to glue corners together, or sides together to kind of make a little pocket to put the anode into it, because what in like with copper or with a copper, with a chunk of copper, as copper electrons are getting pulled off of this thing, some stuff is being left. Like there's a surface of oxidized copper that develops on the skin of the anode, and sometimes the electrolyte will dry out and stick to the anode. And it just there's extra impurities in copper, and that stuff does not come across. What you're getting onto the onto the cathode, onto the thing being plated, is pure copper. And so like the stuff that isn't that generally just sloughs off into the liquid, and it's nice to be able to keep the what do you call it, the
Waste.
yeah, that all that collected together, and so that's what the Swiffer cloths were. So the other thing is, how do you I talked a little bit about making the noun conductive. Basically airbrushing is what I went with. Basically, I bought some carbon ink or graphite ink, and like diluted it with rubbing alcohol, and then that worked very well. It dried very quickly onto my test pieces, and I was able to just spray that stuff on. So let's see. Right. So current. So in addition to current, there's also a nod at voltage. You don't want the voltage necessarily to be that high. With my, basically because the voltage will if your power supply allows you to push voltage or change the voltage significantly, then you're going to heat up your electrolyte, and you're not really adding to the system. You're not being productive with the voltage, where the amperage is what's actually doing the work of pulling copper atoms and putting them onto the material. So there's the ratio for the relationship for current is for every square inch you want to have it about 100 milliamps. So that's that's the rule of thumb, and it's basically estimating. But let's see. Right. If you're just creating lots and lots of bubbles, as you're if you drop it in and it's just blowing bubbles out, you're probably pulling too much copper onto the cathode, too quickly, and you're going to wind up creating very intricate structures that are made of copper, but they're just going to fall apart. Like, they're very fragile. You want the plating to happen relatively slowly. In the case of this little bug that I was plating, I think it took about an hour from start to finish once I got the settings right. But yeah, it's relatively fast. But if you're like, there's a happy medium between plating and just pulling copper off the anode unproductively. So let's see.
You mentioned the liquid is poisonous, right?
Mm-hmm.
Do you need to worry about ventilation from?
When I didn't. Maybe.
I didn't know. Okay.
Yeah, I mean, worst case scenario, they're like, if you're in an industrial setting, you probably should, but like it's putting not a lot of extra stuff into the air, and by the time if it's splashing, you're gonna have a bad time. This should not be doing any kind of this should not be exciting at that point. Let's see. Yeah, so with current, too much is not good. Not enough just means, or either if your power supply is smart, not enough means it's just not going to turn on. Like, you've got your settings wrong, and the power supply is like, you don't have me hooked up to anything, so I'm not going to run. Versus, if it actually is running, turning the amperage down, you're just going to have a slower plating, and so it's going to be a little bit more boring. But the brightener, depending on what brightener you have, you're going to need to refresh some of it. The electrolyte will also get dirty. like even though we try and keep it clean, sometimes stuff breaks off and falls to the bottom. Sometimes there's just again, stuff sloughs off of the anode, and so they do recommend filtering the electrolyte in order to clean it. And some of the things I've seen, basically they have like a carbon style filter where they're just dripping the electrolyte through, and it's pulling stuff out. Let's see. So challenges. These are related to some of my experiences. My power supply I found in Hackables, and so sometimes it works and sometimes it doesn't. So it's just a matter of fiddling with it till you get it working. Sometimes, like one of the things that I coated, this shell right here, you can see on the back of it a piece of my paint that was dried on it kind of flaked off, and so that just resulted in, well, now there's nothing for the copper to stick to. So because shell is really super extra not conductive, and so it's there's just a hole there. You could try and repair it. I didn't, because I was just this was a thing I was playing with. Let's see. Again, airbrushing is really a neat way to coat stuff. I've coated feathers. I've done bugs and stuff. You get a lot of the really delicate pieces coated with the ink with an airbrush. So, and airbrushes also, you can buy them from Harbor Freight. They're pretty cheap. Let's see, safety. I like to nod at safety, but
promptly ignore it. Politely acknowledge.
Right, yeah. I don't want anybody else to make mistakes. Acids, like we're dealing with two different acids in this recipe. They're be aware they're acids. Put your pour your acid into the substrate, not the other way around, because splashes are bad. Also, when using the airbrush, I did wear a ventilator, just because graphite's probably not great to breathe, and.
I can barely read the bottom line. Could you read that for everyone?
Yeah, this message was brought to you by the ass who changes ballasts on live circuits while drinking craft beer on a 20-foot tall ladder. On top of a table.
Yeah, because the ladder was only 15 feet.
Anyway, conclusions. Stirring hot plates are kind of fiddly. Getting the little stir bar steady while you're pouring the root kill in was a little tricky. In hindsight, I could have just stirred it with a stir rod, and that would have been less effort, but I had the thing. Yeah, and the trick to not make it a big deal was to pour small amounts of the root kill to the water. Any extra questions?
Would the brightener change if you're plating a different metal?
Yes, absolutely. I actually wrote that down in there and skipped over it. Yes, the brightener is very specific to the metal being plated. Thank you. Yes.
Less a question and more a comment on your graphite substrate. I've had really good luck using a spray-on graphite lock lubricant. It bonds
Oh.
really well to the object itself.
Okay, cool.
You can get it at the hardware store, just in this little lock section.
Huh.
It's in a spray can.
Cool. I'll have to look for that. Thank you.
I just use it in an airbrush booth, and I don't even have to worry about the mask.
Yeah. Hmm. Okay.
Breathing right in.
Let's see. So, thanks go to Ashley, my understanding wife, and the mother of my 2-year-old daughter, who is very cute right now. Yep. I have other pictures that didn't quite make it into the slide, but they're, yeah. So this was the bus bar that I was using to. It's just a big, like an extra piece of copper wire that I had stretched across the thing. So, but,
Did the sulfuric acid you get in those little tubs with the pipe on top?
No, I had to be very careful because with O'Reilly they sell it to you in a cardboard box.
Yeah.
With a thin bag full of the
Wine
sulfuric
box.
acid. Yeah, exactly. And they have like a rubber a tube that is sealed shut, like heat sealed shut. And so I very carefully cut just a slight hole in that tube and drained that into the container that I was, into my measuring beaker.
They
So-
got that refill in the bike.
Yeah. Yep. But anyway, I am over a little bit, I think. But
Just
that's-
imagine you smashing it like a Capri Sun and blasting it into the.
Gallagher.
Yeah.